I'm Stephen Foskett, organizer of Tech Field Day and Gestalt IT, and we are here at Pure Accelerate 2019. We are actually pretty thrilled to be part of this because not only is Tech Field Day 10 years old this year, but Pure Storage is 10 years old. I didn't realize that the two companies basically started at the same time. And Pure is pretty familiar to a lot of folks who've been part of Tech Field Day and Gestalt IT over the years. You might also recognize Kaz here. He's been presenting, I just checked, you actually presented in September of 2011, so about a year after the company started for the first time. And we've seen you again and again, obviously at events and at Tech Field Day and so on, so welcome. I'm glad that you could join us for a little chat.
Thanks for having me. I well remember that was the one we did on the fourth floor at 650 Castro right after we came out of stealth.
Absolutely. In fact, I think that was pretty much like
that was
right when,
that,
right?
that was right when. I mean, we had VMworld, and then the Storage Field Day was right after that.
Exactly, and I mean that was so cool because I actually sometimes refer to that when we're talking to companies for Tech Field Day, because it was like, you know, it wasn't a presentation meeting room or anything. It was like the office.
Yeah, we didn't have any meeting rooms you could do a presentation in.
Yeah, exactly. And I look back too, and it was funny. Like it was the whole crew. Like Dietzen introduced it. You know, I think Kix was there.
Kix was there. Kix was the MC. Yep. He organized the whole thing, and
and Hayes,
he did a lot.
And yourself,
Hayes and me, yeah.
And that's so cool, you know. And that was like, was that even less than a year after the start of the company?
No, so we started October 1st of 2009.
Oh, 2009, yeah.
Right.
Okay, so that was
it was
2 years.
Yeah, just under 2 years. You know, when you start a company on the first day of the month, it's always easy to figure out exactly how many days, you know, weeks, months, and days, or years, months, and days, I guess, you've been in business.
Yeah. Well, my son was born in January of 2000, so I always know how old he is.
And if it was January 1st, you'd know to the day.
I'd know to the day, yeah. Unfortunately, it wasn't. Sorry, Grant, we tried. Cool. So you were 2 years in, but you had a product, and that product actually resembled the current product dramatically. I mean, it was basically all the pieces were there.
Yeah, I mean, for the flash array, it, you know, at the time, you know, it didn't have some of the more advanced features, like snapshots still weren't there, replication still wasn't there, but obviously the focus on simplicity, all the technology to enable Evergreen. I mean, you couldn't do Evergreen until you had a second product.
Yeah.
But all the technology to enable it, you know, the HA wasn't working yet, but it was, you know, we had it designed and it was just being developed. But yeah, it largely resembled today's product.
So were you shipping at the time?
Betas.
Betas.
Yeah.
So those beta sites, think back on those. Did any of those customers, well, I assume that they kept the systems, right? They kept using them in production and so on. Are any of those systems, you know, I'm thinking of, you know, Ship of Theseus. Are any of those systems still alive today?
Well, given our Evergreen model,
exactly,
none of those pieces of hardware are. But there's at least 2 or 3 of them that are still alive.
Yeah, it's the old story, like my grandfather's axe. You know, this is my grandfather's axe. I replaced the handle 3 times and the head twice.
Yeah, and with Evergreen, it's more like that.
Yeah.
We have at least a couple of customers that have been through 5 or 6 generations of flash array over the last 7 years since we GA'd.
And of those original customers, so you said that a few of them are still using it.
Yeah.
I wonder, do you think it's possible that any of the original bits are still around from those systems? Like anything that hasn't been changed in all that time? You know,
I'm trying to think of it. I mean, it would be one of the drives if it was, and I don't know the answer to that
Probably
one.
A power cord. I bet you've still got old power cords.
I bet, but no, I'm confident that, you know, so think about it, when somebody replaces the controller and they take out the old controller, the new controller came with new power cords. I'm sure they plugged in the new power cords. I mean, the old ones might have gone into some pile of unused power cords somewhere, but
screws, brackets.
yeah,
you
I
know.
mean, you got to remember the product is all about the software.
Yeah.
The hardware is just the current thing the software is inhabiting.
So yeah, but it is a good idea to refresh those power cords, because the modern ones actually are much faster than the original ones.
With power cords, I didn't know that.
You didn't know that? You didn't realize that? Yeah, they're much higher performance. They're 32
The power
gigabit
supplies
power
are better. Oh, come on.
Anyway, so okay,
You could actually, I will point out, you could, by using better conductors, actually get technically a faster power cord.
that would be interesting. Yeah. So okay, so fast forward then. The next time we saw you was in 2012. And what features had you added kind of the next version, the next year?
So in 2012, so we were GA.
Yep.
So that means the HA was now working, and the biggest thing we would have added at that point would have been the snapshots.
So, and by that point, I remember I had a long discussion with Kix about the idea of basically being a big fish in a small pond or a little fish in a big pond. So I always felt that Pure Storage was a maker of mainstream storage arrays, period. And he always felt that no, we are the leader in all-flash storage arrays. And I understand why you're going for that, but for me, the thing about Pure that really, the defining element of the flash array was that it was mainstream. It was the Toyota Camry. It was the Tesla Model 3. I mean, it was the mainstream, everybody can use this storage system.
Yeah, so, well, I get to say you're both right.
Okay.
But, you're right that a key part of it, right, our goal, our long-term goal, has always been to revolutionize the storage industry, to completely do a new thing. And there you have to build something more like the Camry.
Yeah.
Because I'll argue even a Tesla, because of the charging infrastructure and the cost and stuff, it's like you have to build something that every consumer out there says, yep, this is in my budget, this is what I'm going for. And that's what we always wanted to do. So yes, we were the first company to really say affordable all flash and focus on that. You see us doing that now with the Flash Array C. We're going to say now Tier 2 is affordable all flash, and let's make no mistake, eventually I want to be to every storage use case is affordable for all flash. There is no disk is better for this, right? So we're going after that piece by piece. But yeah, it's about being the Camry or the Honda Civic or whatever the most ubiquitous car on the road is these days. Not being the sports car that only an elite few buy.
Exactly, and that was kind of revolutionary at the time, because if you look at the other alleged all-flash arrays, I mean, they were basically ultra-high performance. They were the Tesla Roadster, or the whatever,
the Ferrari,
the Ferrari, whatever. They were intending to be a really high-performance, high-end alternative for niche use cases, whereas you guys were designing for the bulk of the market.
Yeah, I think, the other all-flash arrays were doing that, and then you had all the people who did hybrids because they said, well, all-flash is too expensive. And clearly now you look back at it and you say, okay, every second that they thought about a hybrid, every moment of engineering that they wasted on that hybrid was a waste, right? Because the market has moved and is moving further and further to the all-flash. And that's one of the reasons we were able to beat all the hybrids, and then the all-flash vendors, as you said, it was all about building the Camry instead of the Ferrari.
Exactly.
And people at Pure think Tesla's much more disruptive in many ways, and wish I could come up with a better set of Tesla analogies to use there. But Tesla, hopefully they'll get there at some point and get the really everyone can afford it one, and we'll get enough charging stations and things like that.
Yeah, and it was interesting because around that time, 2013, 2014, you started seeing, as you said, there was this entire explosion of hybrid arrays. And there was also this movement from those, like the Violins of the world, to try to produce a mainstream all-flash array to compete with you guys. And, you know, that was like Ferrari producing an economy car.
Yeah.
And, you know, the other ones were like, you know, Ford producing an all-electric. Yeah, they'll get there, but their first one isn't as compelling.
Well, and obviously for a lot of the startups, they never really will get there because,
Yeah.
it's the big guys who will get there, and it just takes them a few attempts to do it. It's been more exciting, frankly, to watch their attempts to mimic Evergreen, where they're just handicapped by having designed their systems for 20 years, not thinking about Evergreen, and a whole lot of engineering decisions they made along the way get in the way of that.
Yeah. Well, and you could say the same about a lot of these other features. I mean, you talked about like scale out. Was that hard to bring to the platform? I mean, how do you bring scalability to a platform?
You bring it piece by piece. You bring it by focusing on what's needed, not on what isn't needed, right? And that's, that's the way any startup should be thinking, but it's also really the way any any larger company should be thinking. Scale out versus scale up.
Yeah, I just meant scale.
Scale. That's an architectural choice, right? What you do is you sit there and say, what do customers need? Do they need larger? Do they need more objects? Do they need more performance? And how do I deliver it? And I may choose scale out, I may choose scale up. I may choose to optimize this routine. I may choose to redo it and get something that's a tenfold improvement. And that's what tends to happen. You create an algorithm to do something like a snapshot. It needs a certain amount of memory. You then start saying, oh, I'm going to have more snapshots. I'm going to have bigger arrays. And you improve it. Oh, I need a little less. I need 10% less memory per snapshot, 10% less compute per snapshot. And then one day you say, I want to make a big improvement here and this isn't working. And you think, how do I redesign it so I don't need 10% less, but I need 10 times less? Yeah. And you keep doing that, and you keep doing that. And so over the years, we were looking at it with our Evergreen, and people sort of say like, hey, a lot of times I go to a new controller and I don't get as much of a performance boost as I could have gotten over the 3 years. And what they're not realizing is, well, wait, when we first sold you that array to running on the same hardware now, you've gotten like a 60% performance boost from improvements to the software. And now we're adding another 10% or something, or 15% with the new hardware. You got to look at that total improvement. And it's a case of relentless improvement.
Yeah. Yeah, it really is. I mean, I think the Pure story is more about Evergreen than it is about all flash.
Yes, it's the enduring differences are the simplicity and the Evergreen, not a lot of people have all flash now.
Yeah.
Right? Flash was a catalyst. Flash helps enable the simplicity because you don't have to care as much about the geometry, but it's the simplicity and the Evergreen that is the enduring difference.
Yeah. So, as I said, so we saw you in 2012, we saw you in 2013, and 2014. We saw the introduction of the FlashArray//X with a new sort of the back end changes, and the NVMe drives and all this kind of stuff. What was the biggest challenge in evolving the FlashArray platform to where it is today?
I think the hardest challenge was deciding to actually create our own hardware. Around 2013, we had done the 300 series. We had the 400 series in progress, the 420, and then we were working on the next generation, or we knew we were going to do with Intel's new processors, the next generation of the 400. And we beefed up our hardware team. And the new people we came in with some strong ideas of their own. And they laid out a case for, hey, here's how we, instead of having two chassis with cables between them and then shelves of disks with cables between them, okay, let's put it in one package and it'll be a lot simpler and it will get higher quality and lower costs and it'll just be better in so many ways. And, I'm like, well, no, why do we want to do that? We want to remain off the shelf. And it took them a while to convince us it's like we should do this. And, the FlashArray M and then the X is the successor, and that has been a huge success for us. And it has been a great degree of improvement in the simplicity. Right? We were a ton simpler before with the 400, but with the 400 we were selling 20 or 30 terabyte arrays that would have 5 chassis to mount and a whole slew of cables between them, and the cables fail plenty when you wiggle the cables and things. With the M and now the X, one 3U chassis, you put like 366 terabytes in it, you use the data reduction, you're probably getting a petabyte effective in that one chassis, one pair of power cords, one set of Ethernet cords to the management, and then one set of cords to the SAN, and none of this connections to other chassis and things. Yeah, you go to a bigger array, you'll get some connections to other chassis, but the vast majority of arrays can be in this one simple form factor, and it makes it better for the customers, a lot better for the customers. But it was a change to us in how to think, and so for that team to convince us to undergo that change was probably one of the more challenging things.
So you mentioned building your own hardware. Of course, you also were building your own SSDs, and that was a big challenge.
Yeah, well, that was part of the same decision.
Yeah.
So, and again, I'll give credit to the team that proposed it. They wanted to do that all together, and we're like, oh God, no, that's way too big. So we made them do it in 2 steps. So that's why you had the M and then the X. And it's really around building something that's more fit for purpose. It's the same flash. It's the same controllers as were in the SSDs. It's the same parts. And part of that is the agility. Tomorrow, if one of the SSD manufacturers came out with something that was vastly better, some major breakthrough, we can just slide them back into our system because we still have the same slots. Our own flash modules, what they have on it that's really different is our own firmware. And, what fails in the flash? There's no moving parts. Yeah, eventually it reaches end of life, but that's way out in the future. What fails is the firmware in it. So, the guys that make the SSDs, whether it's Samsung or Toshiba or some other manufacturer, they have the problem of saying millions of people are going to buy this SSD. They're going to use it in a million different ways, and our firmware has to deal with all that. And we have to have this complicated little file system. It's a flash translation layer. It's really a file system inside to deal with any workload. We can write firmware that deals with one workload, the Purity operating system workload. And by dealing with that one workload, we're seeing failure rates that are less than a third of, and the SSDs we were using, they're good quality. We're already seeing like order of magnitude fewer failures than a disk, but we cut that failure rate by over a factor of 3 by going to our own flash modules. We also get better performance out of it and better lifetime because it only has to deal with one use case, the Purity use case.
And I know as an engineer, it's maybe less interesting, but is there also a financial factor in building your own?
For the larger scale, there's a little bit of a financial factor, although a big part of that is that we get to use more of the flash because we can use it more efficiently. For the smaller scale ones, no, there's no financial factor in it. It does give us better performance, so it means with fewer flash modules, we can get the same performance that we needed. Gives us better lifetime, fewer failures, and it's like that's really what it buys us.
So, in the following years, what other major hardware changes were made to the original FlashArray platform after the M and the X?
We went to a shelf that was designed to handle our own modules. So that's our Xenon add-on shelf that we have. And I think the other thing you're going to see in the future is we're going to continue down the flash path. QLC, we will be able to use that much better because we have our own firmware. That's going to become more valuable as we ship QLC. We go to PLC or whatever's next there. The same thing. That's where it will really pay dividends. And if the vendors, if the flash vendors or other vendors start coming out with things that are as good, so that advantage goes down, we will retain the agility to just switch back to what they're doing. Yeah. That agility is incredibly valuable to an IT organization. It's incredibly valuable to a manufacturer like us. And that's also why we have the agility even on the controllers and everything. Our core philosophy has always been the data is the array. The hardware is just where the data is currently inhabiting. And so with that, same thing. If suddenly Intel made awful processors and AMD processors were super fantastic, and we could only buy servers with them from one place, we could switch to that. The software we sell today still supports 400s with disaggregated controllers and shelves and such. Maintaining that agility is really valuable and important to us.
So are there any of those old systems still up and running?
There are. There's actually still, I believe it's about 5 of the 300 systems that, despite all our attempts to get people to upgrade, they wouldn't. They weren't from the original customers who bought like pre-GA or at GA, but I think there's still like 5 of those. There's a few hundred of the 400s, and we offer upgrade things. It's actually probably like 1,000 of the 400s now that I think about it. And so our Evergreen X now, one of the things that was targeting was trying to get the 400s to upgrade, as well as the M. So that program is a program that lets you replace your entire array, the storage and the controllers, with a new array. And again, no migration. You just replace it piece by piece. Replace this piece, then replace the other piece.
And but people are always hesitant to upgrade and mess with things that are running. It's work, even if it's not work.
So they should be less hesitant. And you're right. That's a very interesting. There's the sort of if it ain't broke, don't fix it philosophy, and that works good to a point. But there's a certain point where the risk of failing to upgrade becomes significantly greater than the risk of an issue during the upgrade. And that's the point. Everybody should strive to find that point and upgrade at that frequency. And that's something, by the way, where Pure One helps. So we have all the phone home data coming in.
So you know what that is. Yeah.
We can go to a customer and we can figure out, like, okay, here's the release you're on, here's the stage of your hardware, here's exactly what you're doing. So here's like the odds of all these bugs that we've fixed since then that you might hit, and problems with your hardware that might be about to crop up, or firmware levels or whatever. And we can kind of figure out, it's like, yeah, you really need to upgrade. It's the same thing. When we find some new issue, we know who to target from that. And then you got to convince people to go through the upgrade. You're right, it's a step. And the question everybody should ask is it more risk to stay or more risk to move? And once it's overwhelmingly more risk to stay, you should move.
Yeah. So let's rewind a bit. So we also had Pure Accelerate start, and we were there, and we got a briefing on a brand new product line, FlashBlade. You want to talk a little bit about the genesis of FlashBlade and where that's come?
So around early 2013, we said, okay, we're shipping our first product, time to start thinking about our second product. And so a group of us started talking about what to build. And we had a lot of ideas. I mean, we had all sorts of ideas.
We were talking last night about some of those ideas.
Yeah, we talked about a few of them. And we ended up settling on FlashBlade. And, much as I would love to say that, like, the flash array is the greatest product, it's the best thing for all storage, well, it isn't. There are, different parts of the storage market that have different needs. And so thus was born FlashBlade. And as an example too of those different needs, FlashBlade is a scale-out product and was from day one. The part of the market it's trying to serve, the part of the market it's trying to fit in, demands that extreme scalability. FlashBlade focuses a little less on data reduction. It has it, but it's not as much of a focus. Again, the data for the kind of applications they're going after tends to be less reducible. So FlashBlade was born to address, sort of data analytics, AI and that explosion, and the super scalable part of the storage market, and deliver that, deliver all flash goodness and pure goodness to that. And so we hired a new team, started building it, because we didn't want to take away from the flash array engineers, because product was still in its infancy, and we gradually built the team up. We GA'd the product, as you mentioned, in 2016, and you were there. And it's been a fun and exciting ride to watch that product become, one of the most successful storage products of, I'll say this century. And that's something that, literally I count on my hands the handful of storage products that have gotten to real scale this century, and FlashBlade is one of them. So it's been very successful.
Is one of them.
Well, so obviously FlashArray is. So in that sense, it's really cool to have done two of them.
Yeah. So will we see another product line ever?
You'll definitely see another product line. I'm not going to say exactly when, but two products is not enough to address everything we want to do. And then we have thoughts about how to bring the same kind of simplicity and evergreen, to the hybrid cloud universe, but also to a little bit more of the IT stack. I think the big focus for the more immediate future is delivering on this promise of hybrid cloud. I should be able to set down an application, the application and its data on-prem, and I should be able to decide tomorrow, that would run better off in some cloud. And without having to learn anything complicated, without having to do some big migration, I should just be able to say, have the data move over there, have the application move over there. Maybe have the data move and not the application, or the application move and not the data, even in some cases. And, a year later, I should be able to, that cloud's not so great for it. Maybe I want to put it in this other cloud, or maybe I want to bring it back on-prem. And just seamlessly do that without the application having to change, without everybody who's running my environment having to relearn things. The cloud is a great tool. Let's let people use it, and let's let people use it for anything effectively.
Yeah, well, that brings to mind, of course, you do kind of have another product, which is the Cloud Block Store, which is basically a re-engineered FlashArray.
Yes. So that's something where, again, I think we've attacked it a little differently. The storage services provided by the cloud do not have the same guarantees that on-premise applications are used to. And so your choice is to re-engineer the application, right? And that's why you see applications that are born in the cloud being differently engineered.
Yeah.
But if I have a database, or if I have an application that I've engineered on-prem, I want to provide those same guarantees in the cloud. Now, some people have taken the approach of, I'll put a physical array into a data center next to the cloud. Well, what's one of the hallmarks of the cloud? Like the ability to burst, the ability to scale. So now imagine if you called up that supplier and said, I want 100 arrays right next to the cloud for 2 weeks. And then they go, it's like, they can't do that. So putting hardware right next to the cloud isn't the answer. And then just taking your software and saying, I can run it in a virtual machine in the cloud isn't the answer either, because, what does the cloud do? It's like, okay, I get a block volume from a service like EBS on Amazon, and I got a slice of a disk. It's not a resilient disk, it's not an HA disk, and I have no way to say which disk it is. So when that disk has a fault, that volume goes away, right? If I said, I'll allocate another disk and I'll mirror it, well, maybe that other slice I got happens to be on the same hardware, and when that goes away, they both go away, right? Because the cloud has abstracted me from the hardware. So what we've done with Cloud Block Store is we've done the work to understand exactly what guarantees each of the cloud services provide, and create something that provides what looks to the customer like the same kind of on-prem array they have with the same service guarantees. It's just using all the cloud services behind it to do it. So in essence, the cloud platform is like another hardware platform for us. I mean, that's kind of the way that you can think about it.
Yeah, and that's how it looks to me as well, even though, of course, it's still, it's a brother of FlashArray, not a cousin or whatever.
Right, and it's important that it be like a twin brother. Twin brother's not exactly the right thing, but like an identical twin in one sense, because we need active cluster to work between on-prem and the cloud.
Yeah.
We need our snapshot replication to work, right? And what you want to be able to do is you want to be able to say, I'll active cluster from on-prem to the cloud, and then maybe I'll run in the cloud after disaster, and then maybe I'll active cluster back, right? Everything has to work. It has to stay in sync, just like if I had two physical Pure arrays. So, and you want to be able to do it from cloud to cloud. Why shouldn't I be able to active cluster from Amazon to Google, or from Microsoft to Amazon, or from Microsoft to on-prem, anything I want?
So, and of course, this family, there's a bunch of brothers. So there's the flash array, there's the direct memory, there's the flash array C, there's the cloud block store, and they're all brothers, and they all work together.
Yes. Part of that is trying to make things simpler and more adaptable. Part of it, why should two products that Pure produces like look and feel completely different? There's no reason for that. We'd be foolish to throw away that ease of use. And Flash Array C is trying to expand, down to the rest of the storage. Right? All Flash has been, here's my performance tier 1 storage, my highly available storage. I'll spend for all Flash on that, and then I'll do a hybrid, or I'll do the cheapest disks I can find for one of these other applications. In a few years, I want to enable a customer to say, I don't care if I'm looking for the cheapest solution for my large-scale storage, that should be Flash too. And that should be some variant of Flash Array C.
And you've bought a couple companies. You've got CompuVert, you've got Store Reduce. You're expanding those things and expanding what the arrays do, what the scope of these products is by making a unified storage array.
Yeah, you want to, they start out with a very focused purpose in life, and then you start to expand their use cases. And part of that is expanding the protocols they talk. Part of it is expanding the use cases into things you hadn't thought of. When we came out with FlashBlade, we were very surprised at the number of customers that wanted to use it to do rapid restore. Right? So backup's a classic thing where disk-based backup really improved the speed at which you could back up and restore over tape, but all the deduplication in the disk-based data protection means that the restores are random access. So I can back up the data a lot faster than I can restore it. And as data volumes have grown, that's become a big problem for a lot of customers. And so bringing all Flash to that means that now when the deduplication fragments the data, the restore doesn't mind as much because it's Flash access speeds, and it can still restore it at a really good speed. That was a use case we never would have thought of as one of the early ones for FlashBlade. And so investing in something like Store Reduce helps augment that path.
And adding file to Flash Array also helps address more of the market. Just like to my mind, just like Flash Array C addresses more of the market, unified storage helps as well.
And you're exactly right. It's about addressing more of the market. File protocols are a lot more complicated than block protocols, so it's a good leg up to us to acquire with CompuVert a very complete file protocol stack. And so we're now integrating that into Flash Array. So for a whole set of use cases, you're going to be able to get mixed file and block, or effectively a file-only Flash Array if you wish. And then there's other use cases for file, and more for object store and stuff, where it's all about the super scalability you get with a FlashBlade. And so it's about having products that do fill more of the niches of the storage market in order to make the whole thing addressable by all Flash.
So just to wrap up, we've gone from that initial Flash Array with just a few folks in that office in Mountain View to how many employees do you have now?
Probably something like 3,500. I don't know the exact number these days, but about 3,500
employees. How does it feel, just sort of looking back on 10 years, how does it feel to look back on that and see how far you've come?
Well, it's, when you start a company, you're always thinking about success, right? You're sort of dreaming of success, and we couldn't have realistically dreamed of being as successful as we've been. So it's been a fun ride. It's been a great ride along the way, and I'm looking forward to making sure that the next 10 years are just as fun and just as good a ride.
Yeah, and I obviously it's not the same scale, but we've gone as well with Tech Field Day and Gestalt IT over the same time period. And you look back on it, you see some mistakes that you've made, but you also see a lot of good decisions that you made over the years, and you see a lot of things that worked out. And so it's been wonderful to have the two companies kind of growing together, and it's been wonderful for us to have Pure, use the Tech Field Day platform as a way to reach people in the community. So thank you very much for that. And here's to 10 more years, right?
Thanks a lot for having me, and I look forward to repeating this interview in 10 years.
Absolutely. So, 20 years from now, I'll be a little gray. Not yet. We'll get there. So thanks for watching, everybody. Thanks, Kaz, for joining us, and all these years for joining us and for being so friendly. If you'd like to see more videos like this, just go to gestaltit.com or go to YouTube. Look for the Gestalt IT channel, and you'll find many more videos from Pure Accelerate, as well as over the years. You can look at Tech Field Day's archive at YouTube/TechFieldDay, and you'll find a lot of great Pure videos, including ones of this guy from almost 10 years ago. So thanks for joining us.